This is SciByte, episode 70, for November 8th, 2012. Hi everyone, and welcome to SciByte, Jupiter Broadcasting's weekly science podcast. This is episode 80! That's unbelievable! SciByte's fresh every morning at Wednesdays over at jupiterbroadcasting.com. My name is Chris, and joining us every single week is our host, Heather. Hey, Heather.
Hey there, Chris.
Hey, Heather, happy episode 70 to you.
Yes, 70.
That's awesome. So what are we talking about this week?
This week, we're going to take a look at painful math. Canadian robotic rovers using a Kinect in science, updates on spacecraft, stories, and curiosity, viewer feedback, and as always, take a peek back into history and up in the sky this week.
Did I say 80?
You did the first time.
Well, I meant 70. I got really I got excited. I did.
You were excited when I thought you were going to say happy science. I was like, happy science, sad math.
I'm sorry. If I said 80, I apologize. It's fair. I'm a goof, I guess. I'm a goof.
That's okay.
All right. Well, I think we should get into our first story because it sounds like it's right up my alley. So let's do the news. All right. See, it's a good thing I have a chat room there because I'm like, wait a minute. What's he talking about? So what is the first news story this week?
The first news story is math hurts. Well, some people's brains some of the time. So the math anxiety can actually prompt the same response in the brain as when you experience physical pain.
I kind of feel like that's what happened to me today.
Yeah. So they've actually had like brain scans, like analyze them, fMRIs. They can actually take these like real-time MRIs. And they had people, with high math anxiety, kind of moderate math anxiety, various levels of anxiety about it. So they're able to do it, and they give them a problem. Be like, what's the validity of 12 times 4 minus 19 equals 29? And, if you have a lot of anxiety, then the centers of your brain that are, trigger pain actually trigger off. Now, just to see it, they give them short word puzzles. See a series of letters and determine whether reversing the order actually spells, real words. So they were, trying to make sure that it wasn't just the stress of trying to figure something out. It was specifically the anxiety of it. So they have, 14 people. So they're like, all right, let's see how you respond to various questions of math. But it's not actually doing the math itself.
Right. It's like stressing out about having to do the task, but the task of it is not that stressful.
Yes. So
that seems like true for so many things in life.
Yeah. So they're thinking that let's look at how how it corresponds to other events. So the anxiety of something itself actually triggers real pain receptors. And, it's kind of one of those science proves the obvious.
Yeah.
You're stressing out about something. You're like, I have a headache. I am hurting. This is not good. Brain dripping out of ear. And it is real pain.
One of the things I've noticed with math type stuff is if I don't think about it, like if it just comes out as like a flow of thought, process, it's not really a big deal. Like if it's a time zone conversion or something like that, I can do it without really any kind of challenge if I'm not actually thinking about it. But if I actually stop and I try to think about doing the math and then try to make the calculation, it all breaks down and I just get all jammed up. I can't really push through it.
Yeah. It's really breaks down like any other phobia. You have to go about treating it in a certain way. Make sure that, if somebody has a real math anxiety, just sitting them down to do homework is not going to help. You have a big sheet of math homework, that's just going to make them stressed out even more. So you stop out beforehand, you write about, what you're feeling or do something to kind of settle yourself down somehow and then move over. I had a, near phobia of ants, oddly enough. And so, like, slowly but surely, I'm like, all right, see them way over there? I'm going to stand way over here, and I'm not going to hyperventilate. And it's okay. So it's getting closer and closer to kind of how you treat yourself or how you treat it itself. I mean, this can even start as early as first grade. So it's not like it's something, that's only, high school or, getting into higher education. It's, even in elementary school, you can cause the pain receptors in your brain to trigger off.
Wow. Well,
it's in this specific fold of tissue deep inside the brain. It's actually weird. It's like just above an ear or something. And so...
Sounds like it's part of our monkey brain or something that was put there when we were doing quite different types of tasks, potentially. Because you think that's
when I was splitting up my M&Ms between me and my brothers, and I was anxious that they would try to figure out that 1 did not equal 3, then that was pain.
Yeah.
I was like, oh, I'm anxious. But then when I was fair, and I was like, oh, 2 and 2, yeah, those are equal. I know math. Then less stress.
Interesting, huh? Well, and it kind of makes you think maybe if you can help children avoid building complexes around this kind of stuff, it would lower barriers to learning.
Yeah. So if even the teacher itself, if they have some sort of anxiety about it, they can sort of essentially pass it on, that attitude, and pass it on to their students. So with any of these, I
wonder what it is about the math of it, though.
It's not necessarily math. That's the trigger.
But what makes math the type of thing that triggers it? So there's a lot of things, types of things that trigger it, but what category of things are those? Because, if I have to take the garbage out, I don't get anxious about that, right?
No,
what is it?
Well, they tested this for math, but they're looking to see what other kinds of things are like it. What I was trying to say is, I like math. I like science.
Yeah.
History hates me with a passion.
Mm-hmm.
Now, study for math quiz, hour. Study for history, 3 hours, still barely eke out the kind of grade I want. So it's that anxiety of I'm freaking out over this test, you're freaking out over that test, is the anxiety overall of working yourself up to get something done like.
That's true. I guess you're right. Yeah, it's that. Yeah, anything that's kind of like that, and it could be a lot of different things. And it kind of while it is a little obvious, I guess it helps maybe bring a little better understanding, or maybe feel like I'm not so weird about it.
Yeah. So it's one of those things where you're like, oh, well, I kind of know that, but now I feel like I have a better excuse.
Or it's like at least I'm not like the only one.
Yeah.
So that's good too.
It's like everybody really feels it, and you're not just working yourself up. You smash your head, you're like, ow, that hurt. Oh man, you like continue to say it hurts, and you're like, now I feel kind of like a baby. And then you go later, you're like, oh, I need a stitch. I'm not a baby anymore. I have validation. There is a reason for this.
Yep. All right, Heather. Well, should we move on? Because I think we might be giving the chat room some anxiety.
Okay,
what do you think?
Let's go.
All right. Oh, guess what? We have a couple of picks for you guys this week because one of the great things about Jupiter Broadcasting is we do try to keep our ad reads to a minimum. I know some shows out there sometimes take 4 breaks per episode to do ad reads. Well, one of the ways we keep that down to a minimum is through either contributions directly by you, our audience, or by using our affiliate systems. And 'tis the season. It is a great time to think of Jupiter Broadcasting when you're doing your holiday shopping, especially if you shop at Amazon or eBay or Newegg or ThinkGeek. Boy, I love ThinkGeek. Mint.com, if you want to just kind of keep track of your finances through the holiday season, might not be a bad time to check that out. Something we've used for a few years here in the Fisher household. Audible. If you use that link down there for Audible, you will get a free book. And if this is if it's your first time, you get basically a credit is what that means. And you get to keep that book even if you cancel the subscription. A book is... you can get anything that could be 17 hours long. I mean, they're quite a range. It's very cool to check it out. So you want to check out audible.com. And then we have extension links down there for Chrome and Firefox. Then you automatically tag your shopping session at even more affiliates than we have linked down there. But say you're at Amazon. You're like, man, I wish I had a great idea for something. Well, Heather has got two excellent picks this week. one that comes out this week.
Yes, Spider-Man.
The Amazing Spider-Man. The new one, the one that just was out in theaters.
Yes.
Coming out on Friday.
Yeah.
And this seems like a Blu-ray get to me.
Yeah, I think so.
Gosh, and Blu-rays, I mean, not that $18 isn't a lot, but I remember when Blu-ray was quite a bit more, and now it's a 3-disc version, and you get the digital copy too.
Yeah, I really like those three versions.
Yes. So I think I did not see this in the theater, so I think I will be buying the Blu-ray of this so I can see it in high fidelity at home.
Yes.
Now, if you are a Star Wars: The Old Republic fan, she's got a pick for you too.
Yes, there is another book, Annihilation. So these books are all really good background story, kind of complementary to the game itself, or if you just like Star Wars in general. These are all canon, stories, so you can still read it, get a better idea of what's going on in this time frame. And there's hardcovers, audios, so you can listen to the Star Wars universe.
Oh, cool. And it's all this stuff too is all introducing whisper sync, so it all syncs between it, which is really cool. So as somebody who, like myself, takes advantage of the audiobook option, they'll do in some cases they'll do like a $3 upgrade. So if you get the Kindle version and then you for like $3 can upgrade to the audio version, and then it syncs between the two. So when you're listening, sometimes you just listen, and then when it's more convenient or more appropriate to read, you just fire up the Kindle version, boom, right where you left off in the audiobook. It's so awesome.
That is awesome.
Yes,
That is way awesome.
I love it because sometimes you want to read it in different ways. So
yeah,
you guys can check that out. And thank you, everybody. Seriously, thank you for supporting this show, supporting this network. You guys keep us going, and we really appreciate it. All right, Heather. Guess what? With all of that done, it's time for the News Bite. All right. What is our first story in the News Bite?
We've got Canadian robotic rovers. Yes, the Canadian Space Agency. They're actually really well known for their robots. They designed the arm on the space shuttle. They have the arm on the space station itself. There's the Dexter, the robot astronaut. They did that. So now they're kind of continuing in that fashion. So they might be the next wave of rovers that go out.
This is pretty cool. I did not realize that was Canada's primary contribution to this type of mission, because you don't hear a lot about their space program, to be honest. I think maybe that's just because we're down here and we're pretty focused on what we're doing. This is really cool insight. I didn't even realize this was happening.
Yeah, so I read this and I'm like, well, that actually makes sense because I recognize them as being part of this. They're designing specific kinds of robots. There's micro-rovers that they're designing. So it's like two little ones operated in conjunction with the larger rover. So tether them together so the large rover can kind of drag them along and move quickly. And then these little rovers, they're thinking, so go to the moon. And there are these permanently shaded craters, which they think, and they've, sort of seen water in the bottom of them. So maybe you take one of the little rovers, dump it over the side, let it, climb down the mountain on a rope in space, and then it can go roll down there, roll around a little bit, do whatever it needs to do. Or maybe you for some reason hit some sort of crevice or area where the large robot can't get to. So little rover jumps out, does, goes, squeezes into a tiny space, does its science. So, I mean, and in the end, you could use these kind of things to learn, even when, astronauts get there. You could use them to work with astronauts.
Yeah, sure.
So
probably the friendliest little rovers you'll ever meet.
Yeah. So they're actually thinking they'll be mission ready by 2020, which isn't that bad, really.
Okay.
And NASA's actually looking at a couple of them. They have, missions that they say they want to dig up soil on the moon, make hydrogen and oxygen out of it. They have a couple of overall, mission directions that they want to go. And Canada is going through and saying, all right, well, we have rover ideas that will fit to those activities.
To me, it seems like, as the technology and the private industry sort of converge and continue to move forward, it seems like we could potentially see privatized attempts to mine minerals in space, right? I mean, is that crazy? Or what about like asteroids? And I mean, wasn't President Bush talking about doing that at one point during his presidency, about mining an asteroid or
various heads of NASA and presidents have talked about going out and mining asteroids, going back and get
maybe this
near
kind of
Earth
stuff
asteroids.
could do that.
It's certainly possible. Yeah, I mean, it all depends. That is what the almost joke of reality is. Around my office or other places, like, how do you get man to space? Make something expensive. Make gold or or rare minerals on something, and we will get there. So, if we find something, there'll be a lot of analysis to say this, spectrographic analysis, go out and say, all right, yeah, this is an interesting one. Do we have a rover? Can it get there? Is it,
We could be on Mars. We would be on Mars in 2020 if NASA announced next week that they found oil with the rover. We would be there. I mean, so
there's oil in them thar red hills.
Yeah, we would go, and they would try to build a pipeline. You're probably right, and those passing by rocks maybe have some precious minerals in them, or like you said, moon and hydrogen and things like that. Places where we might want to work at some point. We could send these little guys to go down and do some of the work for us to gather some of the resources, so that when we got there, it was available.
Yeah, so
farmed.
Yes, armed with arms, literal little robot arms.
Yeah, I don't know. You never know, right? And Canada, why not? Why not have Canada do that? That sounds awesome. That's a good contribution from Canada.
Yeah, and it made I read it. And I was like, whoa, well, they have all this kind of stuff. They have this background of history and knowledge. So their robots were very different from, what I've seen kind of in the NASA program. NASA program is very bigger and better and cram all the instruments you can on there. And they were very, why don't we just make something small and neat? It does its little job.
Yeah.
And then it's happy.
So there you go, Heather. Well, good one. I'm curious to see where that leads. But what do you say? With that news story filed, Heather, let's move on to the 2-Byte News.
Yeah. 2-Byte News.
It's time for
SciByte 2-Byte News. SciByte.
On SciByte.
Wow.
Yeah. I'm surprised we don't scare people off at that point.
That was pretty good, though. I felt like, that was...
We had a jive going?
Yeah, I'm just going to clip that. We'll just use that from... No, I'm kidding. I'll never do that again. I'm sorry, everybody.
No.
All right, Heather. Well, what is the first story in the 2-Byte News?
All right. The Kinect.
Microsoft Kinect.
That Microsoft Kinect on your Xbox in science.
Okay. All right. Well, this is a pretty sophisticated little piece of tech, so I'm curious to see what they could use it for.
So researchers in Scotland have devised a way to use the Kinect as a sensing system to allow hand controls for holographic optical tweezers.
Whoa.
So these are laser tweezers that are basically designed to manipulate really small objects, like at the cellular level. So you have 3 lasers, you can kind of corral something. You split it into 3 pieces, and you kind of bring them together and corral it into the places that you want. So, have it on the edges, move it over there.
Wow.
But fine-tuning that kind of movement, really less than ideal. They're trying to figure out different ways to do it. So one team said, well, why not? So they connected up a Kinect to the device, and they're able to, have their hands and be like, motion so that it kind of clicks onto a laser, kind of move it so that they can move them and see how exactly it worked for hand tracking.
Huh.
Now, it wasn't really precise enough to be able to capture as subtle a details as they needed.
Right. I would suspect that.
Yeah. Now, also, what would be really nice that they say is more like force feedback, so they'd feel the resistance of something as it moved around. So those would be the kind of things that would be increase the capabilities of moving these with a video tracking system.
Well, and you do have to, kind of look at this and say, well, this is Microsoft's Rev 1, and I've read rumors to the effect that they already have higher resolution Kinects that they might release, and they're gonna just keep moving this technology more and more forward so that the controls can be more accurate. Now, The force feedback, that seems like that, that's not really a Kinect solution. That's more like a controller type solution or something like that.
Yeah, well, some of these is like, well, there's proof of concept met that this kind of a thing works. So maybe their team waits for version 2, or maybe they wait for version 2 and tweak it. Maybe they just tweak what they have. There's a lot of different directions they can go. As of right now, they're still going to, it's still useful for research, for a teaching tool, things of that nature. Just kind of, they've even, I kind of read through in one of them that they kind of even think that they're going to make a game of it.
Oh,
so
interesting.
It's like, make science, grab the cell. So more science.
You know what it reminds me of is you've seen various cartoons where there is a remotely controlled robot, or maybe you've seen this in movies and there's somebody who stands up on this platform and this holographic system comes around them and they move in the system and the robot kind of moves. It almost seems like the beginnings of that kind of thing. Like we're watching like the ancestors of that type of technology.
Yeah, well, I mean, think about it. You move by hand much more fluidly. I mean, you write your name with your hand or try to write it with your mouse. There's various things, can you draw a circle? Can you be very precise in this? Is that how best to make it, exactly what you want? Reduce the number of things in between you and the control system. If you make it as direct as possible, as precise as possible, then you can make these fine details and make it very feedback.
And if you made it as natural with as minimal learning curve, like if the Kinect was sensitive enough, like you said, they're trying to work tweezers, and so if the Kinect was sensitive enough where they could actually see somebody just tweezing their fingers, then anybody could walk in and control the machinery just by doing the action. You don't have to sit down and learn controls or anything like that.
Yeah, I mean, there'll be some sort of a learning curve, but a lot of these high-tech devices I can go through and I can use a couple of devices in our lab, a mass spectrometer, and it'll tell me exactly what chemicals are in the sample that I just got from my project. Now, do I have to know exactly what's going on in that magical box of science? No. I can have an idea. Yeah. I know like the basic idea of what's going on.
Right.
Now, am I a chemist? Do I even pretend to be a bad chemist on Tuesdays? Not particularly. I can pretend to be a mediocre one. But so I don't know the details, but I can still get the exact readouts I need. So that's kind of thing where there is a learning curve on how to use a correct instrument. But like you said, to make it very straightforward, then they can actually use it.
Yeah, yeah. It's kind of like touch interfaces. It's much more straightforward to use touch than it is to use a mouse and keyboard.
Yeah.
All right. Well, any other thoughts on that one?
No, I don't think so.
Well, guess what? The SciByte Computron 2000 has a alert condition flashing here. Let me punch it. Oh!
Hey!
It's time for a spacecraft update.
That is right. Our shuttles, the space shuttles, they may be retired, but a couple of them are doing stuff this week.
Oh, yeah?
Yeah. Atlantis, the last shuttle ever to be in the vehicle assembly building down there in Florida, was transported over to the Kennedy Space Center this weekend. So it's going to be there on permanent display. So it's made its track down the road to its new home.
Aw.
Last week, the Endeavour opened its pavilion officially opened at the California Science Center.
Oh, yeah?
And the Enterprise in New York. Now, granted, a shuttle is not the same kind of thing as all the people that are dealing with Hurricane Sandy or all the storms. But the pavilion of the shuttle actually collapsed and it damaged the rear tail fin of the Enterprise.
Yeah, it's a shame.
So it'll be a little while. It was kind of weird. I heard the storm coming in and for a moment I was like, oh man, how's that blown up building gonna take that? And so they're leaving it in place for now because obviously there's a lot of things going on and the sheet is a protective measure. So we'll see how long it takes to get around to that or putting something up so that it is okay for all the storms that are going to roll in.
Yeah,
winter.
There's another one heading just there.
Yeah, I think it just hit or already hit.
Man, wow. Well, so they're going to have to repair that.
Yeah, they will repair it. There's already plans for it. They're going to do it at the earliest opportunity. And so they're kind of leaving everything in place to hopefully be as no more damage than it already is. And they're preparing for when they can get there safely and take care of the repairs.
Yeah, definitely. All right. Well, good news. We've got a couple of stories that have leveled up. A few updates.
Yes. SpaceX, the Grasshopper. It is a reusable vertical takeoff rocket.
I like it already.
Yes. Now, in September, they made a tiny little hop. It kind of lifted off the ground just enough, and then it added back down. And now it's made a second hop. This is a 10-story rocket. This is not just this little piddly little rocket. This is 10 stories tall that goes up. It keeps going straight up, and then it lands, like, back down correctly.
So in the video, it kind of looks small. So I'm kind of glad you clarified, because it doesn't look 10 stories in the video.
No, there is. Let's see. I'm trying to remember. I know there was an image. It might be in one of the stories.
Yeah. I found a rendering of it.
Yeah, but there's one image that I saw. It was like way back, and you see like a couple of little people in a little spot, and it's like, hey, that's an SUV and that's people. Just so you know. I saw that video and I was surprised that it was 10 stories tall as well.
Yeah, but it's very cool that, so do you know how heavy that we're talking?
Off the top of my head,
yeah, I don't see
weight,
it on here.
no.
Yeah, but it seems like it, so the idea would be that it would keep going up and then up and up and up, and it'd be able to hold a certain weight load. So I assume that 10-story thing was weigh quite a bit.
Well, yeah. The whole idea is to literally make a reusable first stage. You know, if right now you have the first stage, blast the rocket or the payload up towards orbit, and then it just kind of falls down, parachutes, it's no good anymore, into the ocean. But this would be an idea of how to get it up there and actually land it back down so you could reuse that part. So they've got a couple of phases. This is, phase 1, phase 2, 45 seconds of launch time, go up to 240 feet, up to 670 feet. At a phase 3, they'll just keep getting higher. Go to 1,200 feet, 2,500 feet, 5,000, up to like 11,500 feet. So they're kind of just taking it in steps, seeing how far they can get, 160 seconds, up to 11,500 feet. So, like I said, they're taking it in steps, and we're seeing bigger and bigger hops, but it's really impressive that they're able to make this, because I've had things that try to make vertical hops. Tried.
Didn't work so well. Tried. It's difficult.
It's really difficult to have that control and have all the control systems so that it keeps a specific vertical. And the bigger it is, the much harder it is to make sure you have a strong enough control system.
Oh.
But it's not going to throw anything off. And for those kind of rockets, you have to make sure the rocket is, the flame itself is very even. So you're not going to have just slightly more thrust on one side,
so
or how to.
Right.
Yeah, so it doesn't tip, or you make the control system able to counteract that.
It does sound tricky. Right, because if you had a computer system that could accommodate fast enough, maybe it could sort of recover.
Well, yeah, it should.
Yeah.
But it's a lot of the how fast do the triggers work. So you say, the left side needs more, more control. So you send out the signal, and it starts, trying to compensate for that. And then between that time, what happened? Are you needing more? Did it tilt back the other way? Is it now tilting to the right, and you've just put an extra thruster on the left, and now you're leaning more to the right? There are a lot of things going on, so we'll see.
Yep.
And it's a really exciting new approach to this, and I'm going to keep an eye on this one.
And go SpaceX.
Yes.
Go SpaceX. Yay. Ooh. All right. Now I see a note in here about a documentary.
Yes.
Yes.
There is we talked about this before.
Yeah.
Chasing Atlantis.
Okay.
It is talked about it back in August. It is a documentary about a group of friends who wanted to follow the ending of the Atlantis shuttle. So they went down, they watched it, they got a whole bunch of interviews of various people, and so they've already got through the filming. The whole film has been completed.
Right on.
And they did it completely self-funded. And now they're looking they've got a Indiegogo campaign, which is sort of like
Kind of like Kickstarter.
yeah, kind of like Kickstarter. So they're actually trying to raise $15,000 now for all the post-production, and now there might be a little bit more filming, but all the editing and things of that nature. So they're not looking to recover. Actually, they said they're not even looking to recover the cost of the project, just the last part of it.
The hard part. Well,
yeah,
just the post-production part, which is difficult and expensive and hard to avoid expensive fees on, I would imagine. Even just getting the software and hardware to do it.
Yeah, I mean, sound design, color grading, get some assistance for research, and they actually need like a musical score.
Yeah. I mean, yeah.
So there's a lot of things to get going that they can't particularly do themselves. So there's a couple of really, I've seen, they've got a channel, so you can see a couple of really cool videos. And actually, one of them that I found amusing was they saw a Dalek from like Doctor Who, and it's a video going, "We are chasing Atlantis to exterminate." I was a terrible rendition because I'm laughing.
Atlantis, and when I find it, it will be exterminated.
It surprised somebody. That's great.
Yeah.
Okay, that's good.
Yeah.
So they have a channel. They also have an interview there with Will Wheaton.
Yes, they do.
Will Wheaton. So
he's in there, and he has a quick "I'm chasing Atlantis" kind of blurb. But he's in there, and a couple of astronauts are in there. So.
Well, very cool. And Indiegogo is actually picking up steam. There's a lot of people that are doing stuff on Indiegogo now. So.
Yeah, I've seen it a couple times now. Never heard about it before this, really, though.
Indeedly. All right, we have another update, don't we?
We do. I teased last week that NASA had some big announcement coming up.
Yeah.
And they did.
Oh, yeah?
So they're actually using data from the Fermi Gamma Ray Space Telescope. They will look at distant blazars to help measure the background light of all the stars that are shining ever. Like now and in the past and ever.
Wow, that's a task.
Yeah. So what happens is a blazar is among the most energetic things in the universe. They are galaxies powered by really energetic black holes. So they let off these gamma rays. And when the gamma rays hit, so they're shining through the universe, and so is starlight. So when the optical and ultraviolet light from stars travels through the universe, even when they stop shining. So star's going out, it's out, but the light from it is still going forward. Because it's like a wave. So you stop making waves, but the waves are still traveling down the water.
Okay, yeah.
So we can take this and go, the gamma rays from these blazars go through, and when they hit a photon, when they collide with starlight, should I say, they transform into an electron and the anti of it, positron. So the light will start being lost. So it's kind of like shining light through fog. The thicker the fog, the more water droplets there are. So we're able to kind of calculate. It's like, all right, how much fog is in different places. And so we're able to estimate how many stars have ever been in the universe.
That seems like stuff we should never be able to figure out. We're crossing a line there.
We're crossing a line of science. Now, there actually have been in the past upper limits of how many stars have ever formed. And they've said, okay, this is kind of the maximum that we think. Now, this actually gives an upper and a lower limit, and they're fairly close together. So it gives us a really accurate guesstimation of the exact number. So, measuring this kind of thing was the primary mission of this telescope. So it actually it wasn't just like a side data in the data. It was actually, this was its purpose. Now, one of the next telescopes, the James Webb telescope, Fermi is kind of looking at the shadows, saying, oh, there's less light here. That means something is there. Now, the James Webb is actually going to look directly at those. sort of trying to look directly at it. So
yeah. That's awesome.
Come through different ways, but I read this and it was like, we have detected all the light of all the stars ever.
That
I was like,
seems
what?
unbelievable. That's amazing.
And I was like, I gotta read more science of this. And I did. It was really interesting. There's a video in the show notes I have, and it helps kind of visualize it. You see a couple of gamma rays flying by, and little blue squiggles of starlight, going all around it. Then one hits it, and it breaks off into two pieces, and then there's just like 3 gamma rays continuing on.
How much do I love that NASA does this? They put these videos out, and they're just so good. They're so good. And does it have... It just has... This one
music.
Just groovy music, yeah.
Yep, just grooving.
Sometimes they actually have voiceovers by professional voiceover people telling you what's going on, too.
Yeah. But, yeah, with a lot of this stuff, it makes a lot more sense if you can actually see it. There's a lot of words and blazars and gamma rays and things, which you can read and it makes sense, but once you see it, it really helps, get that into your brain as well.
I'm just really... I mean, to think that we could even approach the ability to detect how many stars there have ever been.
Mm-hmm.
Wow. Well, you never know. You just never know. It's cool stuff. Very cool stuff, Heather. Well, all right. So people, if you're listening to the audio version of the show, you got to go over to the show notes and check out the video. Heather, actually, in the link, it'll start just at the right time for the good stuff. So you don't even have to worry about watching the whole video if you don't want to, although you could.
Yeah, totally watch the whole thing if you want, but I kind of jumped forward to the exact part where, like you saw in the enhanced video, but right where it indicates how that happens.
Yeah. Wow. All right, Heather. Well, I got a flashing incoming communications light here on the SciByte 2000. Oh, there we go.
Whoa. Hey.
Looks like a little viewer feedback time.
That is right. First, we have Michael Enriquez, who pointed out there is a story about a super Earth found, which is a large Earth-sized planet that could be in a habitable zone. And that fear not, good science peoples. That story is actually on the docket for next week.
Oh, she's already monitoring it.
Yes, so it's there. It's getting marked up and getting notes on it.
Getting scienced and researched.
Yep, it's getting all science, so it'll be here on Tuesday.
Cool.
And the other person, Justin Luna, asked about my educational experience. He's looking into school applications and such.
Oh, okay.
So just a couple minutes here. I actually graduated with a BA in physics, minoring in astrophysics. So I am not super genius. I just love this stuff, and I'm science. So, but in general, if you're looking forward to getting in college and how to kind of make yourself as pretty on paper as possible for resumes or getting into schools, I did a lot of volunteer work in my field. I did all the volunteer work and internships I could grab, both in school and out of school. So in high school, I was doing a lot of volunteer work outside of school that had absolutely nothing to do with it, and that helped. It got me experience in in astronomy, which I loved anyway, and it gave me extra stuff to put on schools, and they say, okay, yeah, she's really serious. And the physics department at my school brought me in because there was an astronomy professor who found me through that kind of stuff. So, in that kind of stuff, and then the obvious, things of saying, be careful of resumes or job things and going, because mistakes creep in really easily. Sending in job interview preferences, I was sending out a whole bunch right before I graduated. I was sending like 15 all in one day, and for one of them, I wrote the wrong name. The email back pretty much said, I'm Sarah, and that was it. And I was like,
you realized what happened?
Yeah, I realized what happened. I'm like, oh, whoops.
Ouch. That's almost as bad as like saying it's episode 80 at the intro.
Well, almost.
Almost.
Yeah, except you can go back and be like, oh, ha, ha, ha. It's 70. So it's a lot easier. So that kind of stuff, check your resumes, and really think about what you're going for. I was also looking at, I have the research job. Am I going for a research job, or am I going to work at the Science Museum? I wanted to find a job somewhere. Now, the kind of things that would make me look good on paper for a Science Museum, very different than a research job. Mm-hmm. So kind of think about what needs to go on there, what is pertinent to what you need to have. Practice writing essays if you need to write essays for why you think you'd be good for our school. Practice a couple, have somebody read them. If you have to go in for an in-person interview, practice. I went in for a whole bunch of interviews. Some of them, I was fairly certain I wasn't going to get the job. I went in anyway because I wanted to practice under pressure, having someone ask me a lot of questions. And one of them, they said, actually, okay, you're a good person. You're not good for our particular work, but here, opens up a desk drawer, pulls out a couple of business cards. Talk to this person because I think their business is actually looking something for more that you're looking for.
That's really good advice.
So it seems like the obvious stuff. Go online if you're doing a resume for science, a fresh one, or for college. Go online, look what do others look like. Be like, okay, yeah, that's kind of the thing that I'm looking for to use. I even looked up what are fancy keywords that people like to see. So all sorts of different things you can do.
Yeah, I'm thinking on that one too.
So, but in general, for schools, you don't overthink yourself. Don't think, oh my gosh, I was an straight A student because I was an AB student. So it's not like it's the end all be all. Once you're into college, nobody really cares that you got a B in history junior year, all year, because you barely squeaked by and didn't get C's in history. So nobody really cares.
Right. Or when you get into the job, nobody really cares what you got.
Yeah. I mean, once you're, in the real world, I've been told, it's like once it took 4 years to get in college. Once you're 4 years out and you've had your job, the job is just as important as school. So,
oh yeah.
Just think about what you're doing. Go forward. Always try to, volunteer or internships or read up on what kind of stuff you're looking forward to. If you can't get the job in your field, then keep up on it. So if I had to get a job somewhere else, then I'd keep, reading the science stories that I need to read, trying to keep up on what's going on, use it or lose it type of thing. So, yeah, and Jehodi in the chat room, resumes really make a difference. I've had to go through a ton of resumes saying, all right, what kind of people are going to fit in this job? Or, I had, how many teams of researchers are going to go out and work at this station? Okay, what people really work together, cramming together pieces of paper. What I've going through, 300 pieces of paper of people, you kind of learn, okay, this is how the words you're looking for, this is kind of layout you're looking for. And it's really figuring out how to put yourself, an accurate representation of yourself, but that looks in one page good or in one essay good.
Right, sell yourself like a product.
Yes.
In a way. Kind of almost in a way, you kind of almost productize yourself.
Yes. And, it's the rule, one page, don't go 2 pages unless you really, really have a lot of stuff.
It's got to be good,
or
though. Really got to be good.
Yeah. Or you have, you've written up stuff and it's been published. So if you have published stuff, then that could stretch you out. But
and if it's not super good, you could always actually say, additional experience or whatever available upon request or something like that.
Yeah. That you're trying to learn. So.
There you go.
There we
Good
go.
tips. And if you'd like to contact the show, you can email us at SciByte at jupiterbroadcasting.com, or just go over to the Jupiter Broadcasting website and click that contact link right there at the top of the page. And there's an option in the drop-down for SciByte, and you just choose that, and it'll go to the right place. Or you can tweet Heather. She is JB_Mars_base.
And I keep an eye on that, so ask me a question, and I generally try to get back on straight back on Twitter or bring it back up on an episode.
Yes, awesome. All right, Heather, should we take a trip to Mars?
Let's.
And lift off of the Atlas V with Curiosity.
Touchdown confirmed. We're safe on Mars.
That's a wheel! All right, so...
every week we will be just as excited, just in case you want to know.
Yeah.
In case you want to know, we will sing crazy 2-byte new songs, we will scream hooray.
As long as there is a radioactive robot on Mars with a laser, I'm gonna find a way to get excited about that.
Yeah, that's a pretty good.
Yeah.
I think that's a good backup plan.
Yeah. All right. So what is the latest with Curiosity?
We got a lot of updates on Curiosity this week.
Okay.
One, all the researchers were working on Mars time.
Yeah.
So Mars is 40 minutes longer. We've seen a couple of videos like, hey, our family is going on Mars time.
Right.
You know, the family's like pointing up at the clock.
And they're looking at their dad like, you bastard. No.
Well, it was like kids in the middle of summer, so they're probably like, sweet, I'm up at midnight.
Yeah,
this
I'm sure
is
they had
awesome.
fun. Yeah, they had fun.
Breakfast.
But they're not. They're switching to Earth time.
Yep, they're switching back to Earth time. They had planned on it that just the first 3 months they would work on that. And then after that, they would switch back to Earth time. So they are now. There's also a lot of the teams, like 200 non-NASA scientists, have been working full-time with them on site.
Oh.
So they've all been living on site all together, Martian time. Now, those teams have been prepping. They're all going to kind of disperse to their various locations in the world, work on teleconferences, web connections, that kind of thing.
Okay.
So it was basically getting the team together. Everyone was on hand working on that Mars time, doing everything they could to have the first 3 months settled in. You know, all the instruments have all been checked out now. They're starting in on the science. They've moving forward on things. So now they feel comfortable enough. The teams are working together. They know each other really well. So now you kind of step back. You know, people can work on Earth time and not disrupt their lives.
Yeah, it's easier for everybody, right? I mean, that's
yes.
Yeah.
Yeah, there was it? I remember the other rovers, some people were staying on Mars time for a really long time. And it was kind of messing them up. Now, there was a watchmaker in California who actually figured out a way. He had to really tweak with all the gears, but to make the watch run on Mars time. So it was like 24 hours and 40 minutes, and that's what it was. And it would like keep track of that time. And it's hilarious. He's like, you wouldn't believe how tough it was to get a clock to run not 24 hours.
Huh.
And accurately every day.
Yeah.
Now, there's only going to be so many of them sold to the specific team that was there and working on it.
Right, yeah. And they had smartphone apps, too.
Well, now you do.
Well, yeah. Oh, well, yeah. Okay. Yeah, true. I guess if this was like a mission from the 70s, yeah, they would
Well, not the 70s. Not the 70s.
Okay.
But, you know, you have a fashionable watch. You're like, it is 4:30 in the afternoon on Mars.
If, you know, to be honest, if I was like, you know, rich and I was into watches, I would definitely want a Mars watch.
Yes.
That'd be a great little collector's item.
Yes. I'm like, how rich am I? Have one for the vault, have one for the wall, have one for my wrist.
So there's no silly humans mucking up Mars. It's just one time. That's so nice. No time zones, no PST, EST, UTC. It's just Mars time.
Yep.
That's, oh man.
His
nice.
one time zone.
Yeah,
one
nice.
Martian time zone. But so they're all pretty happy. They're back on Earth time and kind of getting into the groove of things. So we'll see how things go from here. And some of the analysis is starting to come in.
Oh.
The X-ray analysis. Looking at the Martian soil. I've been talking about this a little bit, how it was going in. You shoot X-rays through the sample. And it actually... So you get some spectrographic analysis. You know, shoot it with the laser and you can kind of see the compounds. But the exact layout of the crystals inside it actually makes quite a bit of difference. So you can see what's going on there. Was it? I come back to it. But what the soil actually looks like is like weathered basaltic soil in Hawaii.
Oh, wow.
And it's funny because they've used that as a simulant. You know, if you want to pretend, you know, if I have a project and they say, all right, you're going to use it on Martian soil. So they sell these like barrels of this specific mixture of, you know, Hawaiian volcanic soil and things of this nature, kind of spike it to the right degree. And that's what I use to simulate. And they actually show that it is very accurate.
How cool. So you've been using the right stuff all along.
I know. And this is going to be the first, you know, X-ray diffraction on Mars. Now, generally, these things, what's cool about this is generally they're like the size of a double wide refrigerator.
Yeah.
I believe on the video you just saw that was like the last bit that was on there. And on the rover, pretty small.
Yeah.
Like a neat little box.
Like a size of maybe like a small little water cooler type, like a like keep your food in there, kind of much smaller.
Yeah. Oh, sorry, my brain popped back into reality. So you have the spectrographic analysis. You see that, and then, but if you look through it, the diamonds and graphite look the same that way, but they're a little bit different.
Okay.
So you look at the structure and the properties through this X-ray diffraction, and you can tell, oh, this is diamond, that is graphite. Diamonds are slightly different than pencil lead, and now you can figure out exactly which one it is. So it's a very detailed analysis that gives very precise analysis that says, all right, it is presence of feldspar, pyroxenes, olivine, amorphous non-crystalline materials. So very things say, all right, this is exactly what it is here. So move on, see where it is elsewhere. But the fact that we can see these, the structures are actually really very handy.
It's so neat, too, to find out that, well, we took a pretty good guess as what we thought would be a close simulation to Mars sand, and turns out, it is. And it also kind of reminds me that a lot of these rocks are made from the same stuff. Just might be a different planet, but it all kind of comes from the same source material.
There you go.
There you go. All right. So with that said, unless any other thoughts on that before we... Oh, no. Was there any other updates? Do you want to cover the methane stuff or anything? I saw you had a couple links in here.
Yeah. The methane. They've been looking for methane in the atmosphere.
Yeah.
There's a couple of different reasons for that. One, on Earth, that is a big trigger to say there is microbial life. There's something going on here. And in the 70s, the Viking, actually, they... picked up some dirt, they heated it up, and they got some readings. Now, it's been argued quite a few times about whether it was actual, what was the reading.
Okay.
But did heating up the soil itself cause something else to happen? Was there bacterial organisms in the soil that triggered it off? But we're seeing that there is pretty much nil methane in the atmosphere. Now, the atmosphere is so thin that, in the past, when there was water everywhere, or, there was rolling rivers as we've seen, if there was, Mars slime on the bottom of their rivers, the methane that it left off would not exist now, or it would be so insignificantly tiny, it wouldn't really be if worth any data.
Okay, so it doesn't really take away any of the some of the conclusions or assumptions they're making about the previous life in water and things like that necessarily.
Yeah, it's just looking at directly now.
Okay.
And through all this, you can kind of guesstimate how fast the Martian atmosphere is sort of boiling off itself. So.
Wow. Very interesting. Great links in the show notes for that one this week. So you guys go check that out, including they have the Curiosity update.
Yes.
There's no Mohawk guy, but there is a very nice gentleman who tells you about rocks.
Yes.
If you want to watch that. All right, Heather. We'll step over here into the time machine because it's time we go back. Right. Here we go.
All right.
Gotta look back this way. I think our destination takes us to about 47 years ago.
47 years.
November 9th, 1965.
Kind of themed as to we see New York and the eastern seaboard parts of it still under, lack of electricity and blackout. And it was actually in 1965, November 9th, that the biggest electricity grid at that time caused a 13-hour blackout in Northeast America and parts of Canada. And that was when the power lines from Niagara Falls to New York were pretty much rocking at their maximum capacity that they could. And one little transmission line relay failed. So one relay failed. Now there was not enough capacity on that line, so it overloaded that line. And so now there's not enough here, so the power tried to go on other lines, and they overloaded. So think of it, you have, your bucket, and you're sliding it into a big pond, and it has rivers going out. Now, if you block one river up, there's going to be more water going through the others.
Sure, yeah.
And so then, now this one is overflowed. Now that one is overflowed. And it got to the fact that it pretty much took down everything. Now, some operators were able to shut down completely their generators, sort of pull it offline as quickly as they could to protect what they had. But, 80,000 square miles, 25 million people. So at the time, that was very large. I think it's still large right now. There was some difference that I saw. Now there was fairly warning that there was a storm coming. At that point, it was trigger instant. There were 800,000 people in the subways of New York. So it's very different, but kind of
intense
odd and
Yeah.
odd, intense, historically echoing here that there was a blackout 47 years ago.
This week in science. Wow. So there you go. That's looking back, but now it's time to look up into the sky this week.
That's right. We have some exciting things coming up, especially if you are in northeastern Australia or the U.S.
Oh.
Now, on the solar eclipse in northeastern Australia, actually going to do what they call like a false start sunrise. About an hour after the sun comes up, you'll have a full solar eclipse. So for about 2 minutes, the shadow of the sun, the shadow of the moon will darken the sun. You'll be able to see the stars possibly for about 2 minutes. So you'll have, the day will start and then it'll come back to not so much day.
This is on the 13th?
On the 13th. So
Okay.
on Tuesday, we're coming up on it pretty quick.
Wow, okay.
So,
How exciting.
because we're at solar maximum, there's going to be a really good chance that you're going to see a lot of fire tongues and things of that nature around the edge of the sun. So you'll really be able to see, we're talking about all these coronal mass ejections and flares and things like that. So you'll be able to see some pretty good stuff. And there's actually going to be a 3-man team capturing it live and feeding it onto the internet. So if you're not there, the power of the internet will bring you the science of the solar eclipse.
I love that.
Now, parts of New Zealand and Chile will be able to see part of it. We'll see a partial solar eclipse. But northeastern Australia, for whoever listens and is there, you get to see the full thing in person. The rest of us will look online. If you're able to see it, either online or in person, go ahead and tweet it, and we will share in your joy and be jealous if you saw it in person.
Yeah.
But,
Although, for those of us watching it on that live stream that you have linked there, it has a countdown, so it's so you can go there, just check the link Heather has in the show notes, and then you just see the countdown. You don't have to remember the date if you forget.
Yep. Or even if you can't see it, you'd be like, go online. Oh, okay. I've still got time. You can see a countdown either way. But for those of us in the U.S., we still have a little bit going on.
Okay.
We have a lunar eclipse on November the 28th.
Wow.
So we've got something coming up too, so we're not all alone.
So we just got a little bit longer to wait, but we get a little show too.
Yeah. Yeah, so we got almost 3 weeks on that one. I'll bring it up a little bit beforehand too, but I didn't want to leave everybody else out and feel all lonely. But we'll be able to see noticeable darkening of the northern half of the moon. It won't cover the whole thing. It'll be partial. It should be pretty visible to the naked eye that you've actually seen it dip down. The eastern seaboard, the eastern United States, should I say, is going to miss out on it. So because the moon will have already been set by the time it starts. The rest of the country will be able to watch part of it. The longest people who will be able to watch most of it is the West Coast and Alaska. So you get to, yep. So,
Nice.
so you get some good lunar eclipse action. So there's,
I'll give you my report.
yep, there's links to the show notes, like we said, for the webcast and a graphic of the lunar eclipse to kind of see if you're going to be in that area to be able to see it.
Mm-hmm.
And we'll bring it up again later, closer to the date, so you can remember that it's happening.
Very nice. Very nice. All right.
Yep. And in general, like we do every week, what is going to be up in the sky on Thursday? Wait, that's today.
Yes.
And that was this morning. That's what I get for pretending the shows are on Tuesdays.
Well, this is the only week where they're not on a Tuesday. Normally, it would be on a Tuesday.
That's true.
So,
But
yeah.
it's
Can't really
okay.
blame you for that.
We got more stuff. Friday, November the 9th at dawn, the moon is going to be up. It's going to be close to Venus in the southeastern skies. So it'll be, So it's going to be there, and Venus is going to be to the lower left. On Saturday, November the 10th, dawn, just before dawn, is still going to be seeing the moon and Venus in the southeastern sky. This time, Venus is going to be pretty close to the upper left of the moon, and to the lower left, you'll actually be able to see another bright object, the star Spica. Venus will be brighter, but there's images in the show notes as well to kind of keep all that straight as the days go by. But in general, this week, Venus is going to be in the east, rising about an hour before dawn. And Jupiter is going to be rising in the east to northeast just after dark.
Okay.
So,
there you go. I
Yep.
love that. Very nice, Heather. Well, there you go. I think that's the whole show, isn't it?
that is a whole show.
Well, everyone, SciByte is generally live on Tuesdays, except for this week, because we moved for the election. But we'll be back next Tuesday over at jblive.tv at 7:30 p.m. Pacific, and then available for download Wednesday mornings, like I mentioned earlier. You can contact the show, SciByte, at jupiterbroadcasting.com. We'd love to hear from you guys. And Heather, thank you for the great show.
Thank you.
All right, everyone. Well, thank you for tuning in to this week's episode of SciByte. We'll see you right back here next week.